Okay, let's get started. I've been really looking forward to this. My name is Rob Eddy. I'm the Technical Director for Resource Innovation Institute. You are in the right place. This is the California Efficient Yields Workshop, the fifth in a series of 6 workshops that PG&E is sponsoring for us, and we thank them for this sponsorship and our relationship and partnership together to improve resource use efficiency and control environment agriculture. This is a case studies and efficiency workshop, which will be a lot of fun because we're going to talk about boots on the ground, actual projects that have been done and improvements that have been made to, again, to improve energy efficiency. Next slide, please. Go ahead, Mary. I want you to talk a little bit about PG&E and some of the things that we all need to know.
Okay, my name is Mary McDonald, and I work for PG&E in our workforce education and training group. We provide free energy efficiency education classes, which this is one of those. And we also, which I'll talk about a little bit more later, is have a tool lending library where we loan energy measurement tools for free to our ratepayers. So we're happy to support RII in bringing this class to you. And I have a few little bit of PG&E business things. This is a disclaimer, which if you could take just a moment to read, it basically says that we sometimes are presenting typical situations and that you will also have to be careful about applying to that information to your specific situation, among other things that are said in here. So go ahead and next slide. This, if you do choose to speak up or we somehow capture an image of you, this says that you are authorizing us to use your image or your sound in our promotional materials. Next. This is our safety message, which we do for every class. And just to quickly say, if there's an earthquake, drop, cover, and hold. Have an evacuation plan. Know where you can go, you and your family or you and your co-workers, and meet there should there be a fire, an earthquake, or the like. That way you'll be able to know that you're all safe and who's missing and who you might need to look for. Have your emergency plan, who would you contact out of the state and the like, and have a go bag packed because sometimes you can have to leave quite quickly. So have a go bag with all your essentials like your medications and water and things like that. And of course, remember your pets. I have cat food in mine. We are here only for an hour and a half, but please do stretch, get up and move as you're taking this class. And I actually was thinking we could get rid of this COVID point, but more and more I'm getting notices that I've been around people who have tested positive for COVID. So it's not gone away yet. Do practice your social distancing, wear a mask, and follow safe practices, please. And there's a website there if you'd like to see it. Lastly, we do really, really appreciate feedback because we always like to improve our offerings to you. So we will have a survey. Click on the survey in the chat box. There are some spaces for written comments, and those are super helpful. And if you want to see other classes, we'll tell you a little bit about the classes we have coming up. And then RII has a few more classes coming up with Southern California Edison. So you'll be able to take part in those. We'll also send the survey out in an email following this class. Next. Okay, back to Rob.
Yeah, I'll take it back over. Next slide, please, Carmen. Carmen Azaretti is the wizard behind the scenes today who helped me with the technology and also fielding your questions. So Carmen's another employee of RII. So we are so glad to be here today. We're going to start off with a poll. Want to know what role do you play in the cultivation space? If you wouldn't mind answering this, we're going to keep it up on the screen until the end of the section. That would be wonderful. That really helps us know how to direct our messaging. Thank you. Next slide. Today's agenda, of course, I'll start off with an introduction and talk about why we're here. We'll talk about why case studies are important. We'll have a case study on greenhouse, then a case study on indoors. I'll talk a little bit about upcoming technology, and then we'll jump into some of the utility and state programs, including that tool lending library, but also some very generous state programs that I think you're going to be interested in hearing about. Finally, we'll wrap up with question and answer. You can also be asking us questions in the chat box at any point in time. Carmen will be tracking those. Some of those we may ask after a specific section, that technical section. Some we may hold to the end, but please, we'd really like to have your questions. Next slide, please. Okay, we're going to do some introductions here. I'm Rob Eddy, Technical Director. My background is in horticulture. I was a greenhouse and growth room manager for 20 years at Purdue University, a research facility, as you can imagine. Prior to that, I was in the corporate world at Dow AgriSciences as their research horticulturist in their greenhouse headquarters. And I was also a consultant over the last 5 to 6 years before jumping into the RII bandwagon. I'm loving being here and hoping to leave the planet a little bit better than I found it, with any luck. Mike, can you introduce yourself?
Sorry, I do unmute myself there. Mike Zartarian. I'm principal here at Zartarian Engineering and Precision Ag. I've an engineering background, but I've also been a medical cannabis grower for over a decade. So we here do facility design of cannabis facilities and CEA facilities of all sizes. And we do commissioning, starting them up, as well as retro commissioning and improvement projects like we'll be talking about today.
Great. Thank you, Mike. John, can you introduce yourself, please?
Yeah, hi, my name's John Burns. I'm a key account manager with Signify, formerly known as Philips Lighting, part of their Philips 40 LED solutions team. I've been in horticulture my whole career. I have a degree from Colorado State and been a commercial floriculture grower through my younger years. Worked at Syngenta on their technical team for a stint, and have been with Philips for the last 6 years, working with LEDs in commercial applications. So,
great, thank you, John. And John and I were talking. We both come from a floriculture background, and how interesting it is to get into the cannabis world, because it really feels to us a lot like cut flower production. Chrysanthemum, football mums, snapdragons, a lot of these have the same poinsettias, have the same sort of cultivation practices. So it's just fascinating. Next slide, please. Of course, when this webinar is over, the learning doesn't stop. You can have access to the virtual classroom, which you'll be able to see recordings of other live workshops we've done. You'll be able to see today's recording after about 48 hours. We also have tip clips, downloadable resources, and connections to the PG&E and other state program tools there. Next slide, please. Upcoming workshops, we're excited about this. PG&E is doing their Code Breaker, Controlled Environment Horticulture 2022 Energy Code. I know there's a lot of mystery sometimes in figuring those codes out. This is the place to get that information. And July 11th, California Efficient Yields, PG&E Workshop number 6, Efficient HVAC and Dehumidification Strategies for Craft Cultivation Operations, which is kind of cool that we're going down that specific road to talk with growers and educate growers of craft operations. We're excited about that. Next slide, please. Okay, let's find out what our poll results are. It looks like we've got most of the folks here are equipment providers or vendors. That's great to hear. It's good that we've got growers. We like this mix. This really helps us out. Consultants, growers, equipment vendors. Great. Next slide, please. We're going to talk a little bit about why case studies. Next slide. Okay, before we do that, let's do another poll. This is one I wrote. I'm really curious about this. Which of these information sources are you least likely to use? I'm trying to figure that out, and how we can do a better job reaching folks who want to learn more about controlled environment ag. So of these 5, which is the least? So fill that out, and we're going to move on with this section. We're going to talk a little about the California cannabis space, which is, of course, the largest in the country, with multiple license types, specialty cottage, specialty, small, medium, large, nursery processor, different lighting types. It's a $4 billion legal market in California and what's estimated as an $8 billion illicit market. The environments are a full mix of, indoor, greenhouse, and sometimes you'll see hybrids of the two. We'll do one phase in the greenhouse and the other phase in indoor. Next slide. It's important as we talk about this, when we're talking about energy reductions, we also need to be thinking about water, since it's such a scarce resource. But we want to always remind folks that there's a nexus between these two, that it takes energy to get clean water, okay? And so there'll be times, particularly when I'm talking at the end about new technologies that's coming along, that I'll be talking about what this water energy nexus means, so we can keep it all in mind. And also that water consumption in CEA also means fertilizer consumption. So so if you can reduce your irrigation watering, then you can reduce your fertilizer, and that helps with your ROI on whatever equipment you use to remediate that irrigation water if you're recycling, okay? Also, fertilizer takes a heck of a lot of energy to manufacture. So if you can reduce watering that has fertilizer in it, you're reducing your energy, okay? Next slide, please. Okay, let's talk about the results of this. The least likely one to be used are vendor sales brochures and websites. Thank you. That is wonderful. That in then it's a tie, second place between trade show demos and conference speakers. Great. Thank you. Next slide, please. Now we're going to get into our technical discussions. We're going to start off with John Burns from Signify, who's going to talk about a case study that's greenhouse specific. Take it away, John. Oh, I'm sorry. Let me do the poll. So in your opinion, what project is the most challenging? I mean, I've got an opinion, and other people that my peers have opinions, and it's not always the same. So what is the most challenging? Basically, a building or a retrofit, but I'm also interested in what you think about a greenhouse compared to an indoor farm. So if you could answer that while John's starting his presentation. Thanks. Go ahead, John.
All right. All right, so this is a greenhouse case study that we did several years ago. This is a project. The company's name is Hydroclonics. They sell their product under Hemp House Farms. The greenhouse is located in Cheshire, Connecticut. Traditionally, this grower, when they originally built the greenhouses, it was a florey grower, like a lot of hemp cannabis growers as they transition come from traditional crops. Also hydroponic lettuce about 10 years prior. So as hemp legalization was going on in the country, we were approached by Hydroclonics, and they were wanting to start cultivating hemp flower in their greenhouses. This was back in 2019. Prior, the grower had used some LED technology, wasn't too successful with that, but traditionally was growing under HPS and was really looking at transitioning to LED for multiple reasons that we can get into. The size of the greenhouse is about 1.5 acres, about 65,000 square feet of production. And that consists of flowering hemp and vegetative hemp. In this specific region, the utility company was Eversource. And we'll get into this a little bit more, but why that's important is, every utility company and their programs they have for rebates is different. And just wanted to point out that This is a project in Connecticut with the local utility Eversource, and this is the program that we did here was under their guidelines. So what was the goal of the project? Well, the grower had traditional lighting, HPS lighting from being a flower hydroponic grower. And as you know, as the LED technology has been commercialized, wanted to retrofit his greenhouse. So he contacted Philips, and we worked with him, and we'll get into it on what that retrofit would look like. I think you guys are going to get a slide deck after this to have. If you want to watch the case study, there's a link to it. I don't think that works at the moment, but it's there for you. So next slide, please. Okay, so we'll start out with the product that we used in this rebate. And it's really important. The product's a big part of rebates and how utility companies, basically make their rebates in their equation. In this specific instance, we used in the Philips portfolio Gen 1.1 top light compact LED. Probably doesn't mean much to the audience, but internally, basically what that is it's an LED that replaces a 1,000-watt HPS. Okay, and in layman's terms, in this specific crop and in this situation in the greenhouse and where it was located, it was recommended to use a spectrum of deep red, white, medium blue. We'll get into spectrum in the next slides a little bit of what that means. This LED was 520 watts per fixture. So roughly it's about half the wattage of an HPS. So you can already tell that if it's a one-to-one replacement, the grower is going to save a tremendous amount of energy. Efficacy. It's really important what the efficacy of a product is. Here we measure it in joules, or you could say watts. 3.4 micromoles per joule. So what does that really mean? Really, what's important is the higher the number, the better the efficacy. So for every watt or every joule of energy you're putting into that luminaire, you're getting 3.4 micromoles out. Okay, so the higher that number, the more light you get per unit of energy. So it's really important to look at the efficacy of a light. In this case, 3.4 micromoles per joule is a very efficient LED. IP66 wet rating. That's basically the highest grade for waterproof fixture, which is important in a commercial environment, specifically greenhouse, even indoor. That rating is something you'll want to look at. Units dimmable is dimmable via control system. It's passively cooled. What does that mean? It means that there's no fans or nothing else that's cooling it. It's all passively cooled from the heat sink. Less things to break on the light. Internal driver. What you see is what you get. So you can see the picture over there. And basically the driver's housed within the luminaire. Some other LEDs, other lights out there, the driver's placed outside of the light, and that comes with different costs and there's different circumstances for that. But it's important here that this product, everything's encased in the luminaire. DLC listed. We'll talk about this several times, but DLC. If you want to seek a rebate out, it needs to be DLC listed. And what is DLC? Design Light Consortium. It's a third party, basically, that tests and validates what the manufacturer is saying. And most utility companies now require that it's DLC listed in order to rebate the light. And again, we're looking at this LED here as a one-to-one replacement. Not all LEDs replace the light. It depends on the light plan, and we'll talk about that more. So I think that's it. Next slide, please. Okay, so in this, we know what we're using the product, light plan creation. With this customer, we basically, what we call an intake form, we captured all the information, dimensions, mounting height of the of where the LEDs would be placed. Basically, in this circumstance, just where the HPS was, and the crop height. What is the crop? Where is the greenhouse located? All these questions we want to know before we basically create a light design. Once we have all that information, we on my team, we work with our plant specialists for recommendations. So the plant specialist will look to see what kind of crop it is, where it's located, is it greenhouse, is it indoor, what crop cycles. They'll recommend a spectrum, and they're going to look at what we call DLI, or daily light interval, basically. So every crop has a DLI, or where it grows optimally, and that's basically accumulating light for photosynthesis, right? So in this instance, in Connecticut, we're looking at what is the DLI during winter, because when do growers want lights in the greenhouses? Basically to optimize winter production. So we really look at what is the light in a specific area. California, obviously, would be much different. And we would say, okay, this is what the sun is giving the crop during December, January. Now let's look at what the crop really needs for optimized production. And then we'll basically come up with an intensity, or what we call a micromole level, to add that supplemental lighting to the crop. Indoors, obviously, there is no sun, so that would be the lights are trying to capture your DLI solely on that light. At that point, it's not supplemental. After we get those recommendations, we move to our application engineer, where he'll take the plant specialist recommendations and the intake information, and they'll create an HPS baseline. So they'll basically copy the greenhouse as it is, and this is for rebate purposes most of the time. But what the utility company wants to see is they want to see what, if a customer has HPS, what is the energy that is being used? If a customer is thinking about purchasing HPS, what will the energy be used? So we want that as a baseline. It shows the savings of what the LED solution will bring. And so we do that as a baseline. Then we follow up with the LED solution, which was recommended from the plant specialist group. And we're looking to target a certain PPFD on the crop. And that is basically your intensity from the LEDs to your crop, and then that ultimately is giving you your added moles per day. What else is important in light plan creation? Obviously, light uniformity. We don't want an inconsistent crop. We don't want hot spots. So we really look at uniformity, and that's where one of the determining factors of why we use what we do within the LED portfolio. If the lights need to be closer to the crop, we might use something else. In this situation, we were able to hang the lights higher above the crop and do the direct row placement with the HPS. And then all this information is then taken and given to the utility company. They'll use that HPS as a baseline, and they'll compare it to the LED solution. And depending on their program, they will basically give pre-approval for some rebate to the customer. We will cover exactly what that looked like in this situation next. Yeah, so in this case study for hydroclonics, it was a retrofit. And so what we saw basically was there was 2,296 HPS 1,000-watt units that needed to be replaced. Okay, it was calculated for the hemp cultivation, the vegetative phase, and the flower phase. And these were the run hours that were calculated. And basically through that calculation, the amount of HPS, the energy per year of HPS was about 9.5 million kilowatt hours. Okay, so that's a tremendous amount of energy. So then you take that and you replace it with a 1-to-1 LED that's at 520 watts instead of 1040. And you can see through that calculation using the LED that you're at 4.6 million kilowatts. So you're roughly about half. So given who the utility company is and how they look at their programs, some utility companies will have a prescriptive program where basically is like, if you switch out HPS to LED, this is what you're going to get. Some people or some programs look at exactly how much energy you're going to save. We kind of prefer those custom programs because it really incentivizes growers to not just to pick any old LED out, but really look at the LEDs and what it's going to save. And so in this situation, that energy savings was 4.8 million kilowatts per year, tremendous amount. And then the next part you see is the rebate was 20 cents saved per kilowatt. Okay, well, do the math right there. That's $960,000 that the rebate was approved for. So the grower was able to get that rebate, use that towards their CapEx expenditure, and was able to, transition to LED and save on that upfront cost, basically. Till to this very day, I still believe it's the largest horticulture rebate that Connecticut has done. So it was a pretty impressive project. Yeah, so takeaways. So what are some things? Work with your local utility company on rebate programs available. The rebate is one of those things that takes the longest in working with all these projects is, we'll get into a project and, halfway through is like, oh, there's a rebate involved. I would suggest to look into the rebates when you're looking at upgrading your lighting, anything like that. Really contact your local utility company, PG&E, and find out what their exact programs are and how you can apply for those, and then based off of that, start researching the LED products. And what do you want to research? Well, you want to make sure it's DLC listed. If it's not DLC listed, you're not going to be able to get a rebate for it. So make sure that that has that listing. And within that listing, if it's DLC listed, that means that there's a mandatory 5-year warranty, basically. So anything DLC listed has 5-year warranty on it. You also want to look at the efficiency of the product, or efficacy, as we like to say. Remember that number of 3.4 micromoles per joule. You want to remember that. Remember those because not every LED is the same. There's a lot of different things going on. It's great that you want to transition from traditional, more energy-consuming technology, but you want to make sure in that transition that you're looking at how efficacious the luminaire is, and how it's built, and what kind of warranty DLC listed. Another important thing that, from my experience in seeing out in the field, is failure rate. You really, there's a lot of different manufacturers out there, really, and this won't be posted typically on a spec sheet, but ask what the failure rate is of the product. If you're buying hundreds, if not thousands of lights, there's some that are going to fail. You want to understand what that failure rate's going to be, because in the end, it might be under warranty. You can get it replaced, but you're going to have to take that light down and hang it up. It's going to cost labor. It's going to cost time. So that's something you want to be aware of. And light plan creation. No two light plans are ever the same. Really know what you're looking at in a light plan. Ask questions. It's very important. Having a well-designed light plan ensures the success of your crop. Installation costs. Another important thing that people don't think about too much is they look at the price tag and of the project of buying the hardware for the LEDs, but they don't look at what the cost is for their local electrician to install them. So make sure you get that too, because that could be as much, if not more, for the installation cost. And third-party rebate companies. If you don't have time or the expertise or the know-how, there's plenty of parties out there that work with PG&E, and you can contact them and they can do the work for you. We work with several ourselves, and so and that's a very good way of going. So I think those are my takeaways.
Yes, excellent, John. I've got a couple of quick questions for you. Well, I guess I'm blown away by the case study saving $960,000. I've heard of a lot of rebates, but that's incredible. I've not heard one that high. And I just want to say before I ask you a question, how exciting this is. We're still learning. The LEDs have not been around forever. I mean, this is still a new industry, and new exciting discoveries made every time is being made over time. We know LEDs have a higher efficacy, so they give more lumens per watt applied to them. So they're already better than HPS. We also know that, well, let me make sure I'll ask you this question. I understand that when you dim them, the efficacy increases. Is that right, John?
Yeah, that's correct, Rob. That is right. We actually do some installs now where we will add even more light to the original install. For example, say a grower wants 200 micromoles. Maybe we add light for 250 micromoles. What's that value? That's value does is you can dim it down. It becomes more efficacious. The other thing it does is you can store that light for a rainy day. What we keep finding out is that as we do more and more research, I mean, this goes with lettuce, this goes with cannabis, this goes with a lot of things, but there's research that goes out, and there's just growers out there say, I have the right environment to drive growth. I need more light. And so by kind of overbuilding, you can get several things going. You can dim them down, be more efficacious. You can have more light to utilize later in life. We have hybrid systems where the HPS is, obviously its life is not as long as LED. So as the efficiency and the light production goes down in HPS, you can raise up the LED to keep your target levels the same. So there's a lot of cool things going on. Yeah.
So you named some more. So we know they're more the luminaires, LED luminaires. That's the correct terminology, right? Rather than the fixture. We know they're more efficacious. We know when we dim them, they have a higher efficacy. We know that you didn't even get to, we didn't have time today to talk about when you have really good control system, you can have those lights not only turning off and on, but dimming according to outdoor sunlight. And so there's another savings that's really impressive. And the same sort of smart programming can shut off the lights for the rest of the day if it has reached the DLI, or in some cases with the software, even if it predicts it'll reach the DLI with the existing amount of sunlight during the day. So now we're getting more and more chances for those lights to become more highly efficacious, more efficient for their energy. And then I'm learning more about the science from some of the plant sciences, showing that some growers are beginning to dim in the beginning of production when the leaves aren't, when the canopy isn't crossing over. They lower the lights, but then as production continues and you get more dense canopy, then they bring the lights up to the highest amount. And so it's another way to kind of shave off a little bit of energy savings on a crop. So I'm so excited about this. And I guess my other question for you was, you're just talking about energy savings. I love that you mentioned installation, because we found that, I know it's not energy savings, but it's a safety factor that our workers could just put those up with basically one hand, as opposed to an HPS, which is a death-defying thing to be doing on a ladder. It's like 30 pounds. But the question is maintenance costs are compared to HPS. Can you touch on that for a moment?
Yeah, that's a whole thing in itself too. Obviously, LEDs have a lot longer runtime. Historically, HPS, and it depends on the crop, but look at your runtime, not necessarily how many years you've had a light, right? It's really how long it's been working. A cannabis operation will be working a light much more, or specifically an indoor versus greenhouse, but the light demand and the run hours is much more on those on that crop. So much more than lettuce or maybe floriculture, for instance. So you want to look at the runtime, but typically HPS's runtimes, 10,000 hours. You're replacing the bulbs every couple of years, maybe even sooner, after so many crops. That's not with an LED. You don't replace the diodes. It's all one unit. And typically those working hours are, 3 times as long. So I laugh because I tell some of my floriculture growers that only use lights for 3 or 4 months of the year. They're like, well, if I, get this, how long will they last? I'm like, you're probably like 10 years from retiring. I'm like, your kids are going to use these, and probably your grandkids will see them up hanging, they last quite a long time. Again, too, it depends on the product and everything like that, but in the general scope of things, a much longer lifetime.
Yeah, and I remember also the recommendation for HPS and metal halide was get up there and clean the luminaires, clean the bulbs of all the grime that gets on them. And not many peat growers do it because it is hard. They can think get really dirty in a greenhouse, depending on the kind of cooling it has.
Well, and now what also has become a thing is food safety, because of the HPS is a lot of the bulbs, they can shatter, and all that glass can fall down on the crop and stuff. You get away from that when you look at LED products. So,
I've had the metal halides explode in 2 different greenhouses I worked in, and it's a safety issue. Luckily no one was hurt, but that's like white hot glass from that inner arc is flying out in the greenhouse. It was actually kind of set some of the plastic trays on fire. It wasn't an issue. I mean, it smoldered out, but it was a scary thing. And so another great reason, safety-wise, for LEDs. John, this has been great. Thank you so much. We better move on to Mike. First, we'll look at the results of our poll question. Okay, in your opinion, what was the most challenging? Folks thought retrofitting a 40-year-old warehouse would be the most challenging. And here, I know I've run into that too. Mike will probably have something to say about that during the course of his presentation, especially if that warehouse has any wood in it, because then you might have aspergillus and other yeast and such. So we'll move on to, I guess we'll probably have another poll question I'll ask. Go ahead, Carmen. All right, so let me move my thing out of the way. Which of these statements is true? So now we're doing a knowledge check, okay? Dimming an LED light improves its electrical efficiency. Dimming an LED reduces electrical use. Both are true, neither are true. If you can answer that, and meanwhile, we'll get over to Mike and let him do his case study. Take it away, Mike.
Yeah. Next slide. All right. So to that point, Rob, this case study is about a New England brick mill building that was from 1895, retrofit, the basement of which was retrofitted into a craft cannabis facility. So, and this is the type of building we see a lot of in New England. So I can attest it is is challenging. Buildings were built differently back then. How about we'll just leave it at that. But this is a tier 1 cultivation in Fitchburg, Massachusetts. Phase 1 of 3, as we see lots of build outs are in this area. Designed in 2019, we designed the facility for them. It's a bootstrapped operator, so it took them a few years to get through fundraising, construction, all of that. So they have a 400 canopy square foot veg and mom space. They're running single level soil with salt nutrients added to it, and 2 720 canopy square foot flower rooms. So a small, the phase 1 is a small facility. We work on buildings of all sizes, but I wanted to exhibit this one as it's easy to get your head around the whole thing. It's only 2 rooms, and it's easy to isolate what the results were because we kind of had full control and visibility, at the panel level to see how we were doing. This is also a fairly low cost build out. I think it came to $200 to $250 a square foot, which is low in this state, where a lot of build outs now are north of $500 a canopy square or per building square foot. Next slide. So it's all electric, and I should mention it was LED off the bat, and got fantastic rebates from the energy company in Fitchburg, which is Unitil. Similar to California, our energy prices here in Mass are extremely high, 25 cents a kilowatt hour, which makes for energy efficiency is not just a nice to have, it's critical to stay in business right now. If you're not energy efficient, you're losing money on every crop. The rooms in this case were already flip scheduled, so the demand was already reduced dramatically by only running 1 flower room on at a time. And then they go 2 to 2, and then the other flower room turns on 2 to 2. So 1 flower room's on at all times. So their average peak demand from their utility bill is about 100 kilowatts. And they're using about 50,000 kilowatt hours a month. Next slide. So their flower rooms, they have 720 canopy square feet, about 45 standard grow lights in there. They have 4 5-ton split systems, and 2 Andin dehumidifiers. So very standard equipment a lot of craft growers are working with. Then just some basic wall oscillating fans that they chose. And then with all the equipment on, the room consumes about 60 kW. Next slide. So they gave us a call back after they had been open for a few cycles, and they were looking to basically take it from where they were, their opening state, to get to sort of full production, hitting on all cylinders. So their target was very much to be selling the best cannabis in the state. They want to keep, as the market for quality, it has been developed, especially in the past year here in Massachusetts, where it used to be that all pounds kind of sold for the same amount. Now the difference between average is like 1,000 to 1,500, and premium is 25 to 3,000. So that's what they were targeting. They wanted to have the best, so they were 25 to 3,000. That's their business plan. That's their margin. They wanted to decrease the microclimates that were in their rooms because of HVAC, so they got more even growth throughout the canopy, which is critical to getting the highest price per pound in this market. And they wanted to get, there's 6 pieces of HVAC gear. They had just chosen a control system and thrown it up, and they needed some help tuning it and getting it to operate at its best. The primary metric they were looking to improve on here was not just increasing energy efficiency or like decreasing their energy use, but increasing their total energy efficiency. In cannabis, often measured grams of flower produced per kilowatt hour of energy in. So in many of these interventions we're going to be talking about, that's the number we're going after. In most cases, we're increasing production or the quality of production, not for often the same amount of energy. increasing efficiency. Next slide. So the way we do this, we approach this very holistically. We're not just coming in there and looking at one specific system. We're looking at the whole building and the plant operation as well. Having both an engineering and horticultural background, it's critical to look at both to get the most out of it and to decide where will be the most impact to start. So we have a lot of handheld instruments that we go through the rooms and really create a profile and a map of where the microclimates are. And then to supplement that, on the right-hand side here, you can see we have these sensors that we have custom built for this application. We built them out of frustration because we couldn't find sensors to look at plants at the plant level. You'll see the white plates there. The plants actually sit on top of them, so we can see exactly what they're transpiring on a given day, which tells us how the plant is doing, but also what load the HVAC system is looking at on any given day. Again, to help us tune it in to use energy in the most efficient way possible. Next slide. So this slide was shared in the last presentation in this series, and I think it is extremely important one and worth bringing up again. And this varies for every single cultivation, but in general, this is what we see. You'll see the 21, half that pie, 21% and 30% is to do with either venting and dehumidifier and air conditioning. So something to do with climate control and air movement. Especially if we're not looking at a lighting retrofit, this facility already had brand new efficient LED lights. So the 38% lighting is going to, and it's indoor, it's going to kind of be what it is. So the best place where we can look to save a lot of energy and also increase productivity of the space is to improve how the climate control gear is working. So that's where we look at first here. So next slide. So our initial findings upon touring the facility is they had poor circulation in the rooms. They had the oscillating fans at the top were just kind of stirring the air on the top of the canopy. They weren't getting it down into the plants very effectively. And that was causing a lot of microclimates. There was one climate above the plants, there was another inside it, there was another down low near the floor, as well as throughout the space. There were hot and cold points all over. This is in part caused by all of the HVAC equipment was not well coordinated. It was all turning on and off at the same time. The sensors weren't necessarily placed in the best spots that represented the averages of the room. So in short, it was all over the place. On their first few runs, they ran their plants really large, which restricted the airflow throughout the room. They were too close to the lights, which were too close to the ceiling. So this is a good example of where changing plant tactics can actually improve the energy efficiency of the space and how it works quite a bit. And all of these were affecting their price per pound quality, as well as just their output and subsequently their grams, their key KPI of grams per kilowatt hour. Next slide. So this is just an example of what we're looking at. So VPD, vapor pressure deficit, it's a combination of the temperature of the air and then the temperature of the leaf and the humidity in the space to determine how fast water is being pulled out and being transpired and pulled out. So this is in the same room. Some places we have a VPD of around 2. Some places we have a VPD of near 0. So that's the entire range that cannabis is grown in and then outside of it. So those plants at 2 are under stress. Those plants at 0 are not happy because they're not transpiring enough to cycle nutrients properly. Next slide. So this is one of our favorite low-cost interventions into many types of systems, and now a standard for us for new facility designs. Love placing airflow underneath the canopy. And this in conjunction with changing their plant tactics a bit, pulling up and skirting the plants so air can flow underneath there better, restricting their height so that it doesn't go for, the plants don't go all the way to the ceiling. By flowing air underneath there, you can get air from the outside of the room that is, supplied by the HVAC system in to the canopy directly, and flowing evenly up through the plants, pulling humidity up through them and eliminating microclimates that are in the canopy. And this increases the efficiency of the system a lot. It gets air efficiently through the room from the supply to the return of the HVAC system, so that cycle, of plant life support can go through efficiently. The HVAC system runs more efficiently, and the plants themselves run far more efficiently and grow much better. Next slide. So the next element here, again, zero cost, using the equipment they have, is tuning the controls and staging them. So what that means is that you stage them so that there's 6 units in this room, 4 HVAC, 4 standard air conditioning units and 2 dehumidifiers. If you are at a point where you need to turn them on, you're out, outside of range, you don't want to turn all of them on at once. It's inefficient. It uses all the energy to bring it down really fast. Instead, you want to stage them so one turns on one at a time. So as you get outside of a set point, you use the least amount of energy and equipment to bring it back down. There are times when you need all 6 units. For example, when you're turning the lights off at night to get down to your nighttime conditions, and when you're turning the lights on to go from night to day. But during the sort of the steady state of the day and night, you need a fraction of that. So this helps keep that room more even. And that one unit being on creates less dramatic dips. It keeps everything moving much more slowly, which is great, generally great for plants. They don't like quick changes. They like gradual changes. We place the sensors from this very simple TrollMaster system. This is not an expensive system, but just, again, it can perform at a high level. It just, the sensors need to be in the right place. So we move them to places that represented the new average of the room much better. And we could see that by having all of those, the sensors with that we showed a couple of slides ago distributed out. So we had a very good view of where the best spots to put the HVAC sensors are. And then not turning on all of this equipment at times all at once saved a tremendous amount of energy, made the climate a lot more stable and uniform, and the plant health improves immediately. And with happier plants comes bigger yields. So next slide. So I'm going to spend a second here and explain what we're looking at. These are from our sensors in the room. I apologize that the graph is in Celsius, but you can see that each of these lines represents a point in the room, a plant, if you will, distributed throughout. So at any given time, you had so at the hottest point in the room was about 30 C, and the coldest was about 20 C. So you had about a 20 degree Fahrenheit difference from any one part in the room. It was different seasons in both of those areas. So just by turning on the under canopy airflow and tuning the controls, this not even counting modifying the plants, this is on just flipping those switches, you can see that there's a lot of variation, a lot of changes up and down. Immediately at that point of flip, you can see that the range at which goes, that there's variation in the room goes way down for both the night and the day. And again, this is a $0 modification. No gear had to be, extra gear had to be purchased to do this. Next slide. So we're still working with these folks. They're great cultivators who are producing some of the best cannabis in the rec market here in Mass. And since we started last year, they've had a 40% increase in their grams, the key KPI, grams per kilowatt hour, that kind of determines the health of their, generally the health of their business. And the quality is there. consistently demanding double of what the average wholesale price in Massachusetts is. And they have had a complete, their crop loss due to yeast and mold has fallen through the floor because they have great airflow everywhere. We also found stuff during the course of the retro commissioning that was just never hooked up. They didn't have all their filters were not all installed correctly. Their UV lights that are in their HVAC system were not all turned on. So with the combination of all these things, it improved the health of their crop and their business dramatically. And this is just wanted to highlight it's a different approach than necessarily where you are doing a full-on retrofit. This is much more of a retro commissioning and a tuning, if you will. Next slide. So I just wanted to hit through a few things here that we see a lot in doing this work that are opportunities that folks can kind of take away and look at their own cultivation. So the things that, again, these waste energy is, so suboptimal plant scheduling and planning. When rooms don't empty and fill, it causes, at the right times, rooms can be empty and that, maybe the lights are on, maybe half the room has been harvested, maybe a quart, maybe there's a couple rows left because you're waiting for one strain to finish and the other lights are on, or all the HVAC's running. It wastes a lot of energy. So better plant scheduling and planning of moving, matching cultivars together and harvesting them quickly and flipping those rooms over and concentrating on that improves KPIs quite a bit. Hop latent viroid and other sort of plant pathogens, they can reduce the efficiency of the plants, which reduces the grams per kilowatt hour quite a bit. You put the exact same amount of inputs in, and then over time, as your plant stock gets sicker and sicker, it's just like this creeping inefficiency that stacks up on itself, and it can kind of sneak up on cultivators. You don't see it day over day, you see it from grow to grow. We see a lot of CO2 dosing meters that are out of calibration. And as the main thing that plants need once you're running these high light levels in cannabis, again, it can kind of look like hop latent, like the plant, you're giving them all the right things and they're just not performing. And a lot of times you think you're running 1,000 or 1,200 or 1,500 ppm, you're actually at 500 or 600. And all that energy that you're producing with the lights is being wasted because the plants can't use it because they don't have enough CO2 in their environment to take full advantage of that energy. pH meters and calibrating them. Nothing is more energy inefficient than just losing a crop because it gets fed a very low or high pH because a pH meter is out of cal. Equipment maintenance. A lot of times when HVAC units lose their charge or are having an issue, they don't die all of a sudden. They can degrade in performance over time. And kind of like this is like the equipment equivalent of hop latent virus. It seems like it's still working, but it's just not working as well. And it's hard to notice day to day. It's much more of a grow to grow, month to month thing. So that's, when something isn't working right, checking HVAC units and having them serviced can often yield excellent results and some surprises. Rooms that never empty of plants are a perfect vector for disease in indoor facilities, which again, lost crops are very energy inefficient. You put all that energy in and then you can't do anything with it. So having those rooms that cause disease ultimately affect the efficiency of the operation. Poor placement and then solar heating of the sensors for HVAC systems. It can be difficult to get them in the right spot. You want to put them right in the plant, right at the plant level. So you're regulating the plant's environment, not necessarily having them like on the wall or somewhere else. And solar heating is that some of these, look for this, some of these get heated by the lights quite a bit, the sensors from the control system. So the sensor reads hot and the humidity reads low. You can overcome this by compensating for it, but then it means that your set points don't necessarily make sense anywhere other than in your cultivation. And it's hard to talk to others about it. So it's just something to check for and be mindful of. Insufficient subcanopy airflow that we talked about was an issue in this case study. and dehumidifiers and ACs fighting that we talked about, having them staged properly. And then clogged filters, changing, we use very high or very low micron filters in indoor ag, like MERV 13, MERV 11. These get clogged, and when they they don't always look it, but when they get clogged, they can take 5 or 10 or more % of efficiency away from your HVAC system. And going back to that graph before, that's 50% of the energy used in these rooms. So you don't want to be losing just 5 or 10% off the top because a pleated air filter is not passing air through it efficiently.
Wonderful. Mike, first of all, I'd say congratulations. This was a great save, basically, that you did. It seems like it was a classic example of a really, really good grower at a craft level, scaling up, but not understanding the technology that changes as you scale up. And it really seemed to me that it comes down to, well, you had so many things that you improved without them having to pay much money. But the idea that all the equipment was coming on at once and turning off at once. It's something that, a grower growing petunias out in the country somewhere, hanging baskets or whatever, would tend to have a step controller that would do that for them. They'd program in those stages. It just kind of comes intuitively to this industry that always works at that big scale. So it's really neat that you stepped in and recognized that. I love the graphs, the before and after data graphs of the rooms. I mean, as a research greenhouse manager, we were doing that all the time, just tweaking with stuff and seeing if we can bring that error line, narrow it down. And yours, it must have been so much fun when you saw those results, because you just nailed it. I mean, it's rare to see someone nail it as quickly as you did and give them such improvement. I guess my question before we move on is, I was really intrigued by your toolbox of handheld sensors. And since we're going to talk a little bit about the PG&E's tool lending library, I want to see how much overlap it is. Do you remember what handhelds you have in that toolbox that you showed us a picture of?
Well, since you asked, I figured this could come up, so I have to read it.
There we go. Yeah.
It's all the key stuff for to determine what's going on in an indoor cultivation. So Apogee light meter,
yep.
MQ500, highly recommended. This is a CO2 meter, so you can tell what how much CO2 they have to work with, and this is a calibration meter, so it's always accurate, and we get it calibrated frequently, so we can trust it. This is a very accurate humidity and temperature probe that we can look and calibrate individual in-room sensors with, as well as what's called a hot wire anemometer. So this measures airflow at a very, down to the sub 1 meter a second. So almost imperceivable airflows you can measure with this. And then everybody's favorite, which is a FLIR camera. So you can see with infrared what the temperature of different things in the room that maybe you can't get to is. And this is critical for looking at, say, the outlet temperature of an HVAC unit that's up, a vent that's up on the wall.
Right. And the leaf canopy, as the plants get higher, closer to the lights, you want to know, are they reaching that point of where they might be damaged? What a great toy box. Thanks for sharing that.
Sure.
Carmen, let's move on to the next slide. Okay, the answer to our first knowledge check is both are true, and you folks nailed it. Well done. Next slide. I'm going to talk a bit about tracking performance and new technology. This will be fun for me. Next slide. I think I've got another knowledge check. Let me just read this off. HVAC units and dehumidifiers should always operate at the same time. True or false? You could answer that, and I'll dive into my next section. Carmen, next slide. Okay, so measuring energy use. We just saw a great toy box that Mike had, and so there are handhelds that you can use for quick snapshots. There are handhelds or small devices that you could use and move around, which is really great. So you don't have to invest to have it installed. But of course, you can at a retrofit or at construction put more metering in. So most plant growth facilities, unfortunately, only have a single energy meter. So they don't know where the energy, they can't differentiate where the energy usage is. So keep in mind that when you're building, you should think about sub-metering that for at the very least, your cultivation area should be separated, have a separate meter than your processing or your office space so that you can really tell. But ideally, more sub-metering than that. But again, you could use some handhelds or some portable equipment for a short period of time to try to come up with some of those answers as well. Power loggers, current transducers, plug load logger. That's the simplest thing. You can see it up at the top there. You just plug it into the outlet, and then you plug your device into the port of it, and it tracks the kilowatts as it operates and logs them for you. It's a very quick and easy way to get a feel for a piece of equipment's draw. And lighting and power sensors, they're kind of an indirect measure of energy being used, but it does help. Now, the reason I mentioned all of these and show some pictures is PGE has a tool lending library. It's an amazing set. I mean, I was kind of blown away when I looked at it. And this is what Mary McDonald, who you met at the beginning, who will talk to me at the end, that she manages. I've not seen a program like this anywhere. And I think if you're in California and you're one of their clients, you should definitely take advantage of this. These are research tools that a lot of research facilities don't have this good of a collection. Next slide. Same thing with water, okay? Most facilities have only a single water meter. A place I worked with at a university didn't have any water meter. And boy, were they surprised when they put one in. So again, sub-metering is possible. So you can figure out where is the water going. And then as you make changes, you can measure it and see if it did improve it. Ultrasonic portable units. And again, this is something PG&E has in their lending library. So it doesn't have to be permanent installation. Also, there are flow meters built into a lot of fertilizer injection equipment. So every time you're irrigating with fertilizer water, you can be tracking that. I'll show you that in a minute. And also inline flow meters that can be tracked by your climate controller. Let's look at the next slide, and I have a couple pictures. So on the left is a fertilizer injection system, and that little light blue and dark blue box at the top is measuring flow. So every time that injector is running, because a hose is being turned on or dripper system is being turned on in the greenhouse, that's tracking. So we could measure that way. And that's the way we can separate how much the water from the whole building is being used for irrigation. And the photograph on the right is inline EC, and pH meters for the actual irrigation lines, and also has a flow meter as well. And the reason it's got those loops is that you need a bypass if you want to do some maintenance or do some calibration or replacement on those meters. You want to be able to bypass around them. But this was tied into a climate control system, so the climate controller can be tracking how much flow there's been. Next slide. So Resource Innovation Institute has software called our PowerScore platform, and we will help you track and measure your key performance indicators for resource use efficiency. All right, your efficiency as far as energy per square foot of canopy, your productivity measure, which is how much energy per pound of harvest, and also your annual facility energy use, kilowatt hours per day. So we will help you. We can help you load this information into our platform, and it'll spit out these numbers, and you can come back and after you've made changes, you can compare and see if you're doing a better job with your energy efficiency. Next slide. So of course, the point is you want to be documenting baselines. You got to, so then you can, once you have the baseline, then you can see if you are really improving. So we will help you track your energy use, your water use, and your emissions. And again, so you could track it month over month or year over year. And then we also do a lot of education and teach best practices, and you can apply those best practices and see what your progress is. Next slide. Okay, this will be fun. Let's talk about new technology on the horizon. I'm always tracking this. So quantum dot films are films that you can hang in your greenhouse that absorb the sunlight and change the yellow-orange part of the visible light spectrum, which the plants don't use that much. It shifts it into the red, which plants use red light for photosynthesis very efficiently. So you're not applying any energy. It's just a film that kind of shifts the spectrum. Same thing with spectrum shifting films that are actually the covering of the greenhouse. The quantum dots are just things you install inside. The spectrum shifting films take green light and shift it to red light. Again, no energy applied. More photosynthesis, higher yield. So just like Mike was talking about, you're improving your production without increasing any energy use. Transparent voltaics, which are solar cells that are transparent, and they can go on the greenhouse, and they can be gathering energy like a solar cell, but also letting enough light in that the plants can photosynthesize. Now, there might be a trade-off there. You probably, all three of these are that I just talked about, all three of these are going to block a little bit of light. So they're probably going to be best used in California and other places where there's a heck of a lot of light. And if you're growing crops that don't need a really high DLI, so you can afford to give up a little bit of it. Light diffusing curtains. These are curtains that they're usually white colored, and these are shade curtains that open and close automatically, and they diffuse the light. And so these photons get scattered, and more light reaches the lower foliage, and you get improvement in photosynthesis and a proven improvement in yield according to the science. And the science is so convincing that most greenhouses built in the Netherlands these days have light diffusing shade curtains. Also, there's a lot of great smart lighting software out there that is, like I talked about earlier when John was talking, that can predict what the day's DLI will be. Some of them actually have historical weather data for your location built in, so it kind of knows what the average day is going to be like. And this, again, is a way to not run your lights as much, saving energy. Plant balances principles. These are described closely in the Plant Empowerment Principles book that you can go out and find. It's called Plant Empowerment, and it teaches you about the physics, treating plants not just as biological organisms, but physical organisms. And then that opens up your mind and your thinking, your analysis to how can I improve this environment to make sure the plant is at its most finely tuned. For example, doing things to keep its leaf temperature, canopy temperature proper, so you don't get dew forming on it. Thermal imaging is being used now for measuring the controlling the greenhouse or indoor farm based on that leaf canopy, or at least partially on that leaf canopy temperature, again, so that you don't let that crop drop below the dew point where condensation would form on it, which might lead to powdery mildew. Also, they show that thermal imaging if you run your watering based on it, you can save 20% of your water. And remember, when you're the water energy nexus, when you're saving water with fertilizer in it, you're saving energy. And finally, AI and machine learning climate control is already here. If you follow the autonomous greenhouse challenge, you'll see the improvements that they've been able to make in yield without workers entering the greenhouses. And that will be implemented more and more as the years come. 5 years, it's going to be, I don't know what it's going to look like. The kind of cool thing is some of the AI, you just kind of layer over your existing system. If you've got an Argus or Priva or Hogendorn system, you can keep that. You don't have to get rid of it. You can layer that AI over the top of it. That was fun. I love talking about that stuff. So don't forget to fill out the class survey. All right. We really, really appreciate that. Next slide. Knowledge check. The HVAC units and dehumidifiers should always be operated at the same time. Good job, folks. You got that right. That's false. Next slide. Now we're going to jump into our utility and state programs. We've got 3 folks talking today. I believe first is Dana Copps, who's going to talk about the AESAP program. First of all, we'll do this poll alert. Have you engaged with the PG&E account manager? If you could answer that, that'd be very helpful to PG&E. Dana, are you there? look and see. Dana, are you there? Are you muted? Okay. Mary, would you like me to cover these? Make sure I'm not muted. Am I muted?
Nope, you're fine.
Great. Mary, are you muted? Oh, I see. Dana's here. Looks like he's just coming in. Dana, are you there? I think he's just coming on. I see the 3 little dots. Give him another second. It looked like maybe he's having some technical difficulties connecting. I'll tell you what, Carmen, why don't we roll down to the AESC and we'll see if Allison can talk to us about the AESC, and then we'll come back to Dana. Well done. Allison, are you there? Would you tell us?
I am. Can you hear
All right.
me?
Great. Yes.
Excellent. You might even be able to see me, but I'm not sure. So I'll keep this very brief. I wanted to provide everyone a really high-level overview to the market access program that PG&E is offering. This is a program for energy saving and load shifting projects. They must be installed by March 31st of 2020. Wait, of 2024. We should have fixed that. March 31st of 2024. So this coming March. Can you hop to the next slide, please? So as a quick overview, market access, also known as MAP, this is an energy efficiency program in which what we're calling aggregators, or you might think of as contractors or trade professionals or some other name, works with customers in order to enroll them in the program, and the aggregators receive incentive payments based on their performance as measured at the meter. The projects are targeting the summer peak period. So the incentives, which are actually quite high for most PG&E or really most California programs, are the highest in between June through September, 4 to 9 p.m., as that is the peak period that's being targeted in order to help reduce load on the grid and reduce the need for outages. One of the advantages of MAP is that there are no cost caps on the incentive. The aggregators will be being paid based on the savings delivered to the grid, regardless of how much the project costs. It is quick to get projects approved. Once we have all paperwork, we approve the project within about a week. And there's really broad measure eligibility. So there's quite a few different types of things that qualify that don't necessarily qualify under other programs. So if you think, oh, I can't do that because it's getting me too code, for example, it would actually work in market access. The program is open to commercial and light industrial sites, and that includes indoor ag. We do look for sites that have at least 12 months of energy usage that we can use as a baseline. And each site has to get screened so that we can determine it meets other various criteria, including some statistical requirements that aren't really well logicked through. You really need to go through our screening process to determine if the site will fit. Next slide, please. So the program status, AESC does have budget available to reserve incentives, and we will continue to take projects and applications until we have reserved all of our incentives. We do anticipate that will happen in the next several months. So time is of the essence. Definitely bring in projects as soon as you can to take advantage of the high incentive rates that we're offering. Also, as a very important reminder, if your project cannot install by March 31st, then it won't work. If it can install by March 31st, then bring it in quickly, and we'd love to reserve some funds for you. If you'd like to learn more about the program, you want to screen potential projects, if you either need an aggregator to work with, or if you are a trade professional who has customers that you'd like to bring into the program. You can also sign up to be an aggregator. You can reach out to my coworker, Tyra. Her contact information is on the slides here, which you will get after the presentation. You can also go to our website, aesc-inc.com/map to learn more information. So that is everything I had. Thanks very much.
Thanks, Allison. That was great. Dana, did you get your audio working? I thought I saw them hooked up. Maybe not. Well, we'll move on then to Mary. Mary, would you like to start talking about the tool lending library?
I think Mary's having some microphone issues.
Oh no, two people having microphone issues.
Do you want to cover high level the tool lending library, Rob?
I will, because I've been looking at it the last couple of weeks. So again, it's a great program and one like I've not seen. It's free if you're a PG&E customer, and I would highly recommend when you get this deck in the email tomorrow or the next day, click on these. These will be active links. Click on these and look, because the tools are. It's not just 5 or 6. It's like pages and pages of different kind of tools for measuring energy and water and light and lots of different things. Next slide, please. I'm not going to be able to talk about this. So let's see. It's Mary or Dana. Are either one of you hooked up to audio? If not, we can do a couple questions of our panel. All right. So let's go back to our panelists. We'll do a little bit of question and answer. We did want to have at least a few minutes for this. Don't worry, you will get this deck. You'll have access to all this information that Mary and Dana were going to cover. So we'll do a few questions now. John, let me return to you. Is there any? We'd like to hear stories about of things you've come across. Do you have any warnings? I know you don't want to name any company or whatever. Do you have any warnings about things that you've seen that really went wrong with a lighting installation and that you wish you'd have been involved in earlier? Like an example, sometimes greenhouse or indoor farm will have the wrong voltage installed, or order the wrong voltage lights for the plugs that they have in their greenhouse. Anything that you can share with us?
Oh, I'm sure there's things. Yes, like you said, voltage. I mean, that's happened before I've seen. Whether it's, typically, hopefully that's usually the manufacturer can help out with that, so that's avoided. But voltage is a big thing. That's one of the first questions.
If you get 270 rather than 120, as I understand, is it more electrically efficient? Explain that too.
Yeah. So your amp draw goes down. You can put more amps onto a circuit. Basically, what we'll see too is, if you're down at 120, the fixtures can run warmer. I'm not an electrical engineer, so I can't speak upon exactly why that is, but there's a lot of things too. And you also have to be very, what I see a lot of times is there's a lot of lights out there and they're built for specific applications. And some of them aren't necessarily built for where they're being installed. And so I see a lot of things out in greenhouses that were originally maybe designed for indoor cultivation, and then they don't work very well, those kinds of things. So you want to, but voltage is one of the first things I find out when I'm looking at someone, and that's typically because I need to understand what in my portfolio I can service the customer with. So
yeah, thank you. Mary, did I hear you chime in?
Can you hear me?
Yeah, we can hear you.
Oh, for some reason it just like stopped off. It just lopped off there.
Yeah, I'm so sorry.
So I'm sorry. I wanted to shamelessly continue to give a plug here for the tool lending library. I do believe we're the largest in the country. We have over 5,000 tools and over 400 different types of tools. So everything in Mike's toolkit, we have the light meters. You can measure solar irradiance, PAR, color spectrum of your light sources. You can do the submetering, both of water and electricity, like Rob so aptly mentioned. You can measure carbon dioxide and temperature and humidity. We have that hot wire anemometer and several types of infrared cameras. So do visit us. I'm actually in the middle of putting something into the chat with my contact information. If you, there's the website there, you can check out our tools. And if you have any questions, you can contact me at the email I'm about to give you. And I'd be happy to give you a free online tour, personal tour. The rest of the questions here are, or the rest of the slides here are really about some programs that are available for incentives through PG&E. So I'm not going to go into those because we're at the end of class, but please take a look at those. I did have to log on and off to get that sound back. Did you? How many people were contacting their account managers? Did we see that?
Thank you. Thank you for the reminder.
Oh, good. So you see, no, there are a lot of people who are not contacting their account managers. And I'd like to emphasize that you all will have an account manager. Can we go to the slides at the end where we review the answers to that? Because on that slide, I have the phone number you can contact. Next one, I think. There we go. There's the phone number, 877-311-3276. That's the Ag customer service number. You can contact them, find out who your account manager is, and get some help finding those incentive programs to help you save money, save energy, bring your bills down. Okay.
Thank you, Mary. Appreciate that. And we're going to sign off by thanking PG&E for sponsoring this workshop series and today's workshop. I want to thank Dana Kotz, Allison Bailey, and of course, Mary McDonald for telling us about these programs and some things that are available to the clients. I also want to shout out to our panelists, John Burns from Signify, Mike Zartarian from Zartarian Engineering. On behalf of Carmen Azzaretti, I'm Rob Eddy of Resource Innovation Institute. Thank you all for attending today.